A second type of EAS reaction in this chapter is called sulfonation. To do a sulfonation, you need something called fuming sulfuric acid. And so fuming sulfuric acid equals, it's not just normal sulfuric acid. It means we have sulfuric acid plus SO3 gas. So this is unique to this reaction. You need to make sure the words fuming are there when you're writing in your reagents, because if it's just regular sulfuric acid, it's not correct. The mechanism below, we're going to start. Again, benzene is the nucleophile in all of these all of these EAS reactions, benzene is always the nucleophile. So the pi electrons come out, they attack the sulfur. We're going to see one of these pi bonds move up onto the oxygen. Again, we are going to lose aromaticity through this process, and here we form the sigma complex. So this is again our sigma complex. And one more time, we can draw resonance. I'm not going to do it again, but I highly recommend that you practice drawing your resonance. We're going to get into more complicated reactions that are going to require you to draw upwards of 11 resonance structures to answer the questions. So it's always good to practice those types of drawings. If you're not comfortable with it, now's the time to start getting comfortable with it. What's going to happen is we are going to have to fix that negative charge on that oxygen on the sulfur that was substituted onto the benzene ring. So we're going to deprotonate our sulfuric acid. We form SO3H, still sigma complex. And what is going to happen, how we pull off that hydrogen there to reform our aromaticity, is we are going to need to use the HSO4 minus to reform our sulfuric acid. Aromaticity has been reformed. We've performed the sulfonation substitution. SO3H has now been substituted onto the benzene ring, and we get sulfuric acid. So this is the reaction and mechanism for the sulfonation EAS reaction of an aromatic ring.